of this topic just like me. Let's give a big hand to our speaker, MJ Tung.
Hi everyone, my name is MJ. So a brief introduction about myself. I work in ActusRayPartners, which is a hedge fund that uses quantitative models. And I've been doing this for the past 10 years or so, working in hedge funds that use quant models to base their investing decisions on. So we use a lot of data, for example, fundamental data, company data, or pricing history, and even alternative data to generate these signals, run them through our models, and generate some trading signals. And what I want to talk to you guys about today is using a framework called Airflow to manage ETL workflows. Now, I must caveat, what I mean by ETL workflows in our domain is basically extracting data from somewhere, doing some calculations on it, and then loading it in some manner for the user to use in some useful way. So let me start by a question. How many of you guys have done batch processing before? Yes, I assume quite a few of you have. So here's some examples of batch processing that we do a lot of. So for example, there could be end-of-day processing. So in a hedge fund, usually at the end of the day, after all your trades are done, there's some jobs that aggregate all your trades, or maybe there's some jobs that calculate your P&L, or maybe you just want to download all the closing prices for different markets or different exchanges. And then, of course, there would be jobs that you run to calculate stuff, right, or to build reports. The most traditional way of doing it is by using cron tab. And you have a bunch of scripts and you just schedule them. Or if you use Windows, you might use Windows Task Scheduler. But what happens when one job depends on another, right? What happens when job B depends on job A? For example, if your calculation job depends on the fact that your data has been downloaded first. So you might use a while loop, like in the bottom right there, in your second job, to just spin and wait until the first job prints out some output file that says it's done, right? So this is all very traditional or native way of doing this type of stuff that I'm sure some of you guys will have seen before. But what challenge demo of Airflow, just to show you guys how it works. So the core concept of Airflow is the concept of DAGs, or directed acyclical graphs, acyclic graphs. And these specify the dependencies between tasks, and it allows you to control what should happen if a task fails, and it also allows you to rerun tasks. So another way to describe it is an orchestrator or a conductor of tasks. So here's an architecture diagram of Airflow. I just want to focus on the middle part there. So there is a scheduler in the middle. So a scheduler, it works just like cron tab. And in fact, you still specify the schedule in cron syntax. So once the scheduler figures out when a task is supposed to start, if its upstream dependencies have completed, then it will start a task, and it'll send it to the executor. And the executor, by default, uses Celery. So it uses a worker pool, and the workers will then work on these tasks. The rest of it is, I won't go into detail on, but it's also controlled by a web UI. So there's a web server to it as well. So how do you design or create DAGs then? Well, here are some considerations to keep in mind when we're trying to create these things. The first is parallelism. So because Airflow is using a Celery executor and has worker pools, it's inherently a multi-processing environment. So that's something to be aware of, because you could have multiple processes accessing the same resource. And it's just something good to keep in mind, and also as we design this thing. The second point is atomicity, which basically means that each task should be all or nothing, right? Because what happens if your task fails halfway and only updates the database halfway? Then do you rerun it? Do you skip it? You know, if you rerun it, you might get duplicate data. If you skip it, then, well, you might have missing data. And the third point is also related to, you know, operations and reruns, is idempotency, which basically means given the same input to a task, every time you rerun it, the output is exactly the same. So that makes rerunning things easy. Now, what are some examples that fail idempotency? So, for example, if your task depends on an input file, but your task also writes to the input file, the same input file, and changes it, then that breaks idempotency because, well, you can't rerun it anymore, because if you rerun it, then you'll get different input and then you'll get different output. And this part is quite key when designing DAGs because it just makes it so much more easy to operate. So, yeah, let's go into a demo. Give me a second here while I open this up. So here's what the airflow interface looks like. You guys can hear me, right? Here's what the airflow interface looks like. It's a web UI. So let's start with the first DAG. It's just a simple demo that I created. And you see it, you know, there's a chain of tasks. So let's go in the code and look at it. So here's the code. Oh, it's too small? Too small, okay. Thank you. Let me... Is that better? All right, so you guys can see this, hopefully. So here's what the Airflow DAG syntax looks like. You see it starts with a decorator, the DAG decorator, and then you pass in some parameters of the DAG. And that decorator goes before the function that actually defines a way in any of the games. And then at the end, I write this out to a CSV as this team's games. So that's the first task. The second one's, again, super simple. It reads the CSV from that's passed in, the path that's passed in, and then it just counts the number of the length of it. And the final one is, again, a very trivial example. This one doesn't even return anything. It just prints whatever you pass in. Team, which is ETL, the Atlanta Hawks, and then I'm passing. But in version 2, you can use both, and I think it's useful to use both. But the functional syntax makes it a lot easier. So let's actually cause an issue here by raising an error and saving it in this task here. So if I want to rerun a task, let's say this one, and I also want to rerun all the downstream tasks because I'm rerunning this. Maybe I also want to rerun the ones that depend on it, right? So I have downstream highlighted, and then I click clear. What it will do is it will clear the results of these tasks, and then the scheduler will figure out that, oh, okay, I need to run this. So you can see that it's now running, and you can see that it's now currently running this task here, this one in light green. And if I refresh again, okay, so now it's failed, right? Because I raised an exception. You can look at the log, and if you see the log down here, oh, there was an exception raised. So if you imagine trying to operate this in a real production environment, right, with more complicated jobs, then this makes things really easy because you can just go in here, you can see what failed. You can see that, well, since this failed, then the ones that depend on it aren't going to run. And if you fix an error, like let's say I now comment out this exception, hopefully that picks up. And then I clear it again. Again, I clear all the downstream tasks, then it's going to rerun it, and hopefully this time it will work. So you see it's running. Still running. And yeah, it's done. So success, the dark green means it's done. Personally, I like to use these start and finish operators to put them at the ends there. So these are defined by just empty operators, which is basically, it means it does nothing. It does nothing and it just has a label to it. It makes it easy because if I want to rerun this, let's say I want to rerun the whole thing, I can go to finish, I can clear all the upstream ones, and that would clear everything, and then it would just rerun the entire thing. So I think that's something useful, and you can do something meaningful at the start and at the finish as well. It doesn't have to be empty. Okay, so yeah, you can see it's running, and it's probably going to succeed. The third example I want to show you is a little tricky thing in Airflow. I just want to share about execution dates. So here, again, it's very similar, but I've changed this task to say I don't want to count all the games. I just want to count the games that are within 28 days of the execution date. Okay, so let me just make sure this actually makes sense. So that's something that sort of tripped me up a little bit, but yeah, I think it does actually make some sense. So let's go back to the side. So shift this back. All right, yeah, I talked about the logical date, and there's some links for you there. I'll post the slides. Oh, sorry. Thank you. Yeah, there you go. So yeah, that's what I just went through, the logical date and some links. I'll post the slides later. Talk about some other interesting bits. External task sensor. So you might think, okay, well, can one DAG have tasks that depend on tasks that live in another DAG? And the answer is yes. You use something called an external task sensor, which senses for the completion of a task that lives somewhere else. There's different types of sensors in Airflow. So there's also file sensor, which is it looks for an existence of a file before continuing. And there's SQL sensor, which is you can run a query and check that the data is in the database before you continue. Pools. Pools are, I think, also a very useful concept. So in Airflow, because we're doing things concurrently, sometimes you want to control how many concurrent processes can access a certain resource. So for example, you might have an SQL pool that controls how many tasks or how many processes can be accessing your SQL server concurrently. By default, everything's in a default pool. So actually, there are ways to get around this as well if you install a custom XCOM backend. So I haven't actually done this yet, but there's ways, for example, to use S3, for example, in AWS as a backend. And that way, then you can store a lot more data, and you wouldn't have to keep writing code to read and write and read and write. Although it's doing that in the backend anyways, because that's what the custom XCOM backend is doing. So finally, just want to end with this slide, some considerations. Want to help you consider, is Airflow right for you? Well, Airflow is completely written in Python, so that's good, and it's appropriate that we're talking about it in this conference. It's you can go into the classes and the methods and easily understand what's going on. However, it's somewhat complicated to onboard, I would say. So before Airflow, I was also trying a framework called Luigi, which is similar. It's also an orchestrator. That's a lot more lightweight. But I found that it just doesn't have that many features and wasn't too much of a value add to actually onboard it. So we went with Airflow. Hopefully I showed enough of the demo that you could see there's actually a lot of features on the UI and a lot of things that you can do with it. The third point is that there's actually quite tight coupling between the Airflow framework, the scheduling, and the application data logic, right? So you could see how everything's specified inside the DAG Python file, and the schedule is there. Your application logic is there, and perhaps you could restructure the code a little bit, maybe import your logic from elsewhere, but still, the way that your jobs run and the way that it chains together is very inherently tied to how Airflow works. The fourth point is that I think Airflow makes operation really easy, as in someone maybe who doesn't even know how to code or anything like that could come in and operate Airflow on a daily basis, right? If they see that task has failed and you can see what the error message is, maybe you could fix it and just rerun things. But maintenance is not simple. Maintenance meaning if I want to upgrade my tasks, if I want to do different things, because of that tight coupling with Airflow, then you would need to know how Airflow works. You would need to know the intricacies of Airflow, those little gotchas, to be able to change the code or to maintain it. The final point is that while the topic of this talk is about using Airflow for ETL workflows, I would say it's not inherently designed for all types of ETL workflows. So like what I mentioned at the beginning, for us, which is we run our models, we run a whole bunch of calculation jobs that take hours and hours to run. We do lots of downloads of data and whatnot. That makes sense for us, right? Because there's a lot of job dependencies, and we want things to be very robust and specified. But there's other types of ETL, for example, like MapReduce. If your data is distributed across many different nodes and you want to aggregate it that way, there's no real feature in Airflow that helps you with that. And perhaps something else like Beam might be more appropriate. All right. So that's 30 minutes. Do you guys have any questions?
Thank you for the very nice talk. I have two questions. How would you compare Airflow versus, say, proprietary tools like Amazon Glue pipelines? I've not used it that much, but that's the first question. Second is, if you have streaming data and you have batch data, then would you end up using Airflow as one and then use a different tool for another? I guess you can't do both using the same tool.
Yeah. What was the first question on AWS Batch or AWS
Glue?
AWS Glue. Okay. I haven't tried AWS Glue before. Although I have talked to AWS, and I think they have some support for Airflow as well. So yeah, that's something that I plan to explore in the near future. But I can't answer about AWS Glue. The second question is about streaming data. So streaming data, I think, at least from my explorations with Beam, I think that probably supports it better. There isn't any inherent thing in Airflow that supports streaming data, I would say. So if you have both, I think, yeah, it really depends on the timing, right? So Airflow, you saw that it's still dependent on that cron like scheduling structure. So let's say if you want to run something every 10 minutes, maybe that could work, and you're taking a snapshot of, or something like that. But if you want to run something that is truly streaming and it updates as you go along, I don't know if it would be appropriate. So yeah, it depends, I think.
Thank you. So I'm curious how Airflow scheduler prioritize different tasks. So say I have some tasks that are very long running, like one for an hour, and then I have 10 workers, and then already 10 tasks running, and then I've already 200 more tasks in the queue. But then now some urgency comes up, and I want to have a new task submitted according to my needs.
I'm not sure that you can dynamically adjust it if the task has already started. But you saw that when I was making changes to the DAGs, that you can just save it. You don't need to restart the whole system or anything like that. So you would be able to, change the properties, which is the priority weight, if it wasn't running already. If it's running already, I haven't tried that. I don't know if you can actually change it. Yeah.
Thank you.
Just a quick question. Can you use the same Airflow instance to run, for example, tasks on both Linux and Windows?
Ooh.
And by instance, I mean the same web view. Now that's not necessarily the same DAG, but like the same, just kind of managed under the same pane of glass per se.
Right. So you're talking about having workers that run in Linux and some workers that run in Windows.
Right.
Yeah, good question. I don't know. I think theoretically it should be possible if you can specify like different worker pools. And but yeah, that's not something that I've tried.
Okay, cool.
I haven't tried to change the worker pool. I've just been using the default one, which uses Celery. Yeah.
Okay, because I assume it's based on wherever you kind of install Celery or Airflow, like whatever OS you've installed it on, it's using that OS to run the task. Is that right?
Yeah, that's a good question too, actually. So I've been running it using Docker. So
Okay.
yeah, just spinning that up in a Docker environment so that it's that is in Linux. But you don't have to do it that way, right? You could install it natively on the system as well.
Right. Thanks.
Hello. My question is, how would you, in your actual work environment, how would you define a DAG or task granularity? Or in other words, how big or how small would you define one DAG or a task? Because you can always make it smaller or bigger.
Yes, that's right. That's right. So the main high-level concepts would be the slide I showed about atomicity, idempotency. So those are important. And also, I think just reasonably, like, is it something that you might want to rerun? And also, is there anything shared? So, for example, you could have a task that it's like a function. It's almost like when you're just coding and you say
to do some migration on the new version of the DAG, or the DAG actually overlap for the expected time they have running.
So you mean you try to do a release while the DAG is still running,
or maybe just they have some concurrent DAG. The DAG was supposed to be finished within 1 hour, and the DAG came more than that.
Yeah, sometimes the DAG can take longer than expected. But sorry, I don't understand what you mean by like you try to change it.
But if this problem can, what is the expected behavior when we are trying to solve this kind of problem? Using the Airflow, yeah.
So how do you solve the problem that sometimes DAGs take too long?
Yeah.
I find that from my experience, one thing is that if you have too many things running at the same time, so for example, you have many different DAGs running at the same time, it can take up your resources. And especially if you've already set up pools to limit your resources, maybe it's eaten up some things in your pool as well. So the most simple way is actually just to schedule them later, right? Or like I know that there are dependencies on each other, and you can set one DAG to depend on another DAG by.
Because S3 is eventually consistent. Is there any way to mitigate that, or do you pass it straight from memory from one task to another task? And a follow-up question on this is how do you aggregate tasks? It's easy to blow up tasks to run in parallel, but how do you collect them, back them into one task? Do you have any pitfalls on that front?
Yes. I hope I remember all your questions, but Okay, so in and out as in. Oh, okay. So yeah, we are using. Okay, well, let me finish up with this question then. So currently, what we're doing is we're connecting to a database that exists outside of Airflow, right? So there's actually Airflow has connectors available to connect to, like, let's say MySQL database, SQL Server database, and it's pretty easy to set up. Had no issues with that. I had also tried using a sort of internal database, like spin up a different database and just attach it to the Docker, and that also works. But since our production database is external, so we just use that. We also write files to disk, so currently not using S3 yet. But yeah, that is a good point, something I should be mindful of if I do use it. So yeah, that's perhaps one way to get around it if that really is an issue of data consistency, right? It's just to write to disk first. So passing data between tasks right now is still writing those files to disk. And your final question about aggregating all the tasks, yeah, that is a good question. So that is something I looked into as well. So we just use a list of tasks. So usually what I do is, like, let's say in that example where I have 3 teams, right? I have 3 NBA teams, and so there's 3 streams. I want to collect them at the end, at the done task. So I can append each task, each of those 3 or 30, whatever it is, into a list, and then I pass that list into the final task to be aggregated. So that can then take in some information from those 30 tasks. Now, there is something to be aware of when using lists in Airflow, and that's another gotcha, is when you're running it, you have to be aware of defining the DAG, which is before the DAG runs, right? So when I'm typing in the code there, I'm defining the DAG. So if I specify a list of strings, it'll be there. But if I'm specifying a list that depends on task results, I do not know the task result yet until I actually run it. So sometimes Airflow will trip out there, and it's it's just something to be aware of. Yeah. Okay. Yep, I think we're out of time. Hopefully that was helpful for you guys.
Thank you for your questions, and I'm sure that you may have further questions for MJ, and you may catch up with him after this session. Let's give a big hand to our speaker. And ladies and gentlemen.